Greetings and welcome, ladies and gentlemen. We're talking today about rational exponents. Does anyone know what kind of numbers rational numbers are?
Ones you don't get in fights with other numbers.
Or I could actually rewrite that as fractional. Fractional exponents. Exactly. Because rational numbers are numbers that can be written as a fraction whose integer and denominator are integers. Right? So let's do a consider here for a minute. Consider this. Consider, right? Remember back in the day, if I had the square root of x squared, what did I do to simplify that? What did that become?
X.
X. And yeah, we had a bunch of absolute value and stuff, but I'm not worried about that right now. What if I had the square root of x to the fourth? What did I do with that?
The x2.
X to the second, x squared, right? What did I do if I had the square root of x to the sixth?
x3, x squared, triple, x cubed.
X cubed. So question, what is the relationship between this and this?
Half.
Half. Where do you think that half is coming from?
The imaginary hobbit 2.
Oh, the imaginary hobbit 2, the little index. So to verify that, was it not also the case that the cubed root of x to the 12th would have been what? X to the 4th, right? So this 4 came as a result of what? Where did those numbers?
The index.
Right. I was dividing what? I divided the index, exponent by the index. I like it. So if I wanted to write the square root of x without a square root symbol, what is the exponent of the x right now? 1. There's a little invisible 1. And what is the index of this?
2.
2. So what would I write this as? X to what power?
The second.
No.
The half.
The 1/2 power. Exactly. Exactly. So that's the idea, is that the index of your radical can become the denominator of your exponent. So let's see. So here's the definition of b to the 1/2. Ready? B to the 1/2 equals the square root of b. Right? And it turns out that's also true for b to the 1/nth. That's going to equal the nth root of b. Right? Because similarly, in our previous example, if I had the cubed root of x, to write that with a exponent and not a radical, what would that exponent have been? Right? This little exponent was 1. I'm dividing by 3, so this is 1/3. Okay? So that's not terribly crazy, I don't think, right? Is it? No? Yes? Maybe so? So, so check this out. Let's do an example. What do I get if I simplify, or maybe I'll evaluate the following? All right. What if I've got 81 to the negative 1/4 power? All right. I just want to point out, remember all of our crazy rules with properties of exponents? If not, remember them, because that would be good. It's even crazier now. Now we can have fractions in the exponents. So looking at this problem, let's just talk about what does the negative do first of all. No. If you were a landlord, it would move what? It would move it downstairs, right? So this would equal 81 to the positive 1/4, and it's super happy living downstairs. Who's living upstairs? 1 is. He snuck in through the fire escape as usual. And now, what does a 1/4 exponent mean?
The fourth root.
It means the fourth root of 81. Let's see, does anyone know what the fourth root of 81 is? I hope it's 3. That would be nice, wouldn't it? 3 times 3 is 9. Another 3 times 3 is 9. 9 times 9 is 81. Yeah, so that was 4 3s. So voila, there we were just able to simplify, and it wasn't that bad. Right? Let's try another one. What if I've got 32 to the 3/5 power? (32 to the 3/5 power. Now, I don't have a rule for this yet. However, I can reimagine this as a power to a power property. Pardon me, I'm just getting some water. Well, I could rewrite this just using my properties of exponents. This is the same as 32 to the 1/5 all cubed. Would you guys agree? Right, because if I multiply 3 times 1/5, I would get 3/5. And Joey, you were saying something about the 1/5. What does that become? The fifth root of 32, all to the third. Let's see, I'll continue down here. Because a fractional exponent, its denominator becomes the index of your radical. Craziness, huh? So yeah, so this guy became that guy. This guy became that guy. It's like he worked his way to the top. He used to be the denominator of an exponent. Now I'm
From the bottom, now we're here.
Yeah.
From the bottom, now we're here.
Oh, okay. I don't know of this song, but hopefully it's appropriate.
Are you serious?
And hopefully I have the license to use it on my YouTube page.
What was the word that Jacob was saying yesterday?
I don't know.
Oh, let's not.
But anyways, yeah, we're in the middle of a video. These people are trying to learn this.
We're fine.
Although, just shout out to my friend, Word Jacob Used Yesterday channel is really good. Go over there, watch his videos. He uses a word every day, but he doesn't post it until the day after, just to stick with the name that he's got. So yeah. So let's see. So what is the fifth root of 32? 2, because 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. So 2 to the 5th was 32, therefore the fifth root of 32 is 2. So I'm left with 2. This little cubed is still hanging out. 2 cubed is 8. 8. 3 squared would have been 9. Okay. Now,
I don't know, I really don't get how you just got to like that stuff all the way up.
from this one to this one?
Yeah.
Okay, well, the fifth root of 32 just became 2.
So that means that 2 times 2 equals 2 times 2 is 32.
You got it, dude. You got it.
And then-
Now,
Okay.
question. Does anyone see a shortcut from here to here?
You just
You just do 5 the fifth root of 32 cubed.
Okay, so this became the index of the radical, and this guy stayed as an exponent. Okay, let's actually look up here. Look up here. Check this out. I also could have written the cubed root of x to the 12th as x to the... You said where did the 4 come from?
Where is the top?
The 4 came from 12 divided by 3, right? So I actually literally could have written 12 thirds power. And then that just 12 divided by 3 is 4. Right? So you actually technically already knew that. So let's put that into a rule. Let's do the definition of rational exponents. Rational exponents. Here we go. let's see. I'm going to write out all sorts of crazy words. Ready? Here we go. I'm going to write out like a formal definition. For any non-zero, there's going to be a lot of math words here. Real number, okay, we're getting way mathy. Real, not mumber, number. B, all right. Man, that's crazy. B's not even a number. B's a letter. What? And any integers. Integers m and n. Might as well get you guys used to some of these formal definitions. With n being restricted to being greater than 1. Oh, classic. Then the following is true. B to the mnth power is equal to the nth root of b to the m. Or you could also write that as the nth root of b to the m. Right? So nth root of b to the m, or the nth root of b all to the m. Same difference. Right? So basically I could exponentiate first and then do my radical, or I could do my radical first and then exponentiate. Those are interchangeable. Except, man, so many restrictions. When b is less than 0, and this is like the fine print. They're like, you can use this rule, except not on nights and weekends and all blah, 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 right? And let's see. N is even. So here's the rule. This is the real thing that I need you to know. And let's actually analyze some of these little restrictions. Non-zero, what does that mean? Could it be negative? Yeah. Yeah, could be negative. Yeah, that's right. That's the only rule. Real numbers, that's pretty much every number you can imagine. All right, because you can't imagine imaginary numbers, can you? But wait, if you imagine if I imagine a real number, is that real number imaginary? That's crazy. That is deep right there.
You know, fear. You can't think of a new color.
Yeah, I know.
That freaked me out the other day.
Wow, man.
I don't need
Dat Crayola, am I right? Crayola is just like cray.
That's crazy. That's crazy. That's crazy. That's
There's
crazy.
some animals that have like
And
a whole bunch more colors in their
anyways, yeah. Save it for Hank's YouTube channel, Colors with Hank.
Philosophy.
Go on over there, check it out. He's got all sorts of videos about how to make tie-dye, how to put animals' eyes into cones, all sorts of stuff. Worth checking out. Definitely check it out. Subscribe. Huge fan. Does anyone know what integers are? Whole number is a subset of the integers. It also includes the negative versions of them. So non-radical, non-decimal. So basically m and n, these have to be like 2 or -7 or 3. They can't be like pi or the square root of 5 or, 1.92, stuff like that. Doesn't work. All right? And b had to be non-zero and real. Okay? With craziness, n is greater than 1. So n itself had to be positive. You can't have a negative root. That's I'll have to consider that restriction. I imagine we could. It just would put it into the denominator. That's unusual to me. But anyways, but what about this last restriction?
When n is even.
What is this situation describing? What is the square root of -4? B was negative, and n was even. That's the second root. The answer is no. I'm not doing that. You can't make me. That doesn't exist. right? There is no square root of negative 4, right? So that's what it's restricting there. So anyways, so that's that idea. Let's actually do some problems with this. Get some problems going here. Let's see. Let's simplify the following. Actually, I could put my little EX in a box. I might as well. Little EX in a box. Let's do x to the 2/3 multiplied by x to the 5/3 power. Now, multiplying two things of the same base. What do I do with the exponents? Adam. There's no one named Adam here.
Never trusted.
X to the 2/3 plus 5/3 equals, let's see, 2/3 plus 5/3. I might even need to find a common denominator for some of these problems, just so you know.
No.
Like, imagine doing a whole fractions problem, but within the exponent of another problem. Craziness.
No.
Right? So x to the, how many thirds is that? 7/3. Now, depending on what they're looking for, if they wanted it listed as a rational exponent, that could be fine. What if I wanted to write this as a radical? What's that as a radical? What would be the index?
No, 3
The cubed root
of x
to the 7th. Or the cubed root of x all to the 7th. Actually, you guys technically know how to simplify that even further. But if they were just looking for rational exponents, you could kind of just leave it like that. But you guys know how to simplify that, right, friends? Yeah. Let's just do that for fun. Let's just do that for fun. Let's see. What's the largest factor of 7? Sorry, not factor. What's the largest number that can add to be 7 that is divisible by 3? So I'm going to break this up into the cubed root of x to the 6th times the cubed root of x to the 1th. Right? Equals, let's see, what is the cubed root of x to the 6th?
X cubed.
No?
Squared.
X squared, because I'm dividing, times the cubed root of x. All right, so if I wanted to write this as a radical, this is the other way. So this is as a rational exponent, rat expo. Man, I wish they had a rat expo every year. And this is as a radical. Someday I'll be a rat king, maybe. Let's see. Y to the negative 5/6 power. Craziness. These exponents have fractions in them. What is going on? So let's see. Negative exponent. What do I do? What's your friend on the phone say, Joey Bag of Donuts?
What?
What's the lifeline say? What's our friend on the phone say about y to the negative 5/6? What do we got? We got, that's over 1. What's the negative exponent? What do we do?
Downstairs.
Downstairs.
Bring it around.
So y to the 5/6. 6. Oh, I hate it. It came back. I didn't even realize it at first, and then I was like, I said that funny, and then I was like, it's the fraction that I hate. I wouldn't recommend you go to 5/6 YouTube channel. So what if I wanted to write this as a radical? Because this actually is not allowed in this current form.
Y, no, 6 root y.
And what don't mathematicians like about that?
The radical downstairs.
Yeah, so is this a binomial? No. So what could I multiply this by? Well, if I multiply by the 6th root of y to the 5th, I'll get the 6th root of y to the 10th. And that doesn't help me. So I have to multiply it by something that's going to give me a perfect 6th, so it cancels. What could I multiply that by to give me a perfect sixth? 5 plus 12 is 17. That's not divisible by 6.
13. That might work.
5 plus 13 is 18, which would work, but would actually have a whole bunch of unnecessary work. What's this? How about this? 1 plus 5 is 6.
Oh my god. Think of that, Agnes.
But 5 plus 13 is also 18, which is divisible by 6, so that also would have worked eventually. So I'd have the 6th root of y over the 6th root of y to the 6th. And actually, I believe, funny thing, from this point on, I believe that we just assume that all of these are positive integers, so you don't have to worry about. What is the 6th root of y to the 6th? Why? Because I asked you for the answer. That's why. And so I could write it that way if I wanted a radical answer, or I could rewrite this as y to the 1/6 over y if I wanted a rat expo. So this is, so sometimes it'll want it one way, sometimes it'll want it the other. And actually, oddly enough, you could have avoided the whole radical work if you wanted. It's possible that I could have actually multiplied this by y to the 1/6 over y to the 1/6 and added these exponents, and I would have gotten y to the 1st and y to the 1/6 up top. So there are some like techniques if you become really familiar with rational exponents that you can do stuff like that. Let's see. Don't pack up yet, friends. I need to do one more example. Actually, where is it? Yeah, I know. I got the time.
No minutes.
Incorrect.
You have like 1 minute. 2.
Yeah, 2 minutes. 2 minutos. What if I wanted to simplify this? What if I want the cubed root of the square root of x?
Oh, wait, what? That doesn't make sense.
Well, what does a cubed root mean? Don't tap out. Guys. What does a cubed root mean?
That, how many times? 3.
If I want to rewrite the cubed root as a rational exponent, what would that be? It'd be a
1 over 3.
1/3 power. What does the square root mean as a rational exponent?
1/2 power.
What do I do with the power to a power property?
Just add
You could, and then I would multiply. 1/2 times 1/3 is 1/6. So here's my rational answer. My radical answer would have been what root?
3.
The 6th root, because 6 becomes that guy.
Now what happens?
All right. Thanks for watching, internet friends.